And now we proceed with the last presentation in this session. It's from Dalma Günter, and she will present us an open access tool on the position calculations in the LAN.
Good afternoon. My name is Dalma Günter. I work at Center for Energy Research, colleague as Balázs, and I'm just finishing my master's studies in biomedical engineering. And today the main goal of my presentation is to introduce OpenSLM website or web-based simulation platform. In the first half of my presentation, I will shortly review the Institute developed stochastic LAN model, and then I will perform a demo run on the website. Many of you may already be familiar with the stochastic LAN model, which was introduced in previous years by my colleagues Günter and Árpád Farkas. Because of that, I will only give a short introduction to it today. As you all know, aerosols, especially fine and ultrafine particles, can penetrate deep into the respiratory system and pose respiratory and systemic health risk. The deposition distribution of the inhaled particles depends on several factors like particle characteristics, breathing pattern, and Irving geometry. An Austrian-Hungarian project aims to develop a model to incorporate anatomical variability into lung exposure calculations. The stochastic approach used detailed anatomical data for trachea, bronchia, and pulmonary airways. They used these data sets to determine probability distribution describing the structure of human airways. These were then integrated into stochastic lung model. This model treats case parameters as random variables, I mean airway length, diameter, and breathing angles. This model allows captures inter- and intra-individual differences more realistically. This slide shows the structure of stochastic lung model implemented in Rust. On the left side, you can see the input parameters which have to be defined by the user. We can define particle parameters like size and density, and personal breathing parameters like functional residual capacity and tidal volume, for example. The model based on measured geometric data. This data first processed with statistical analysis. From this distribution, geometric parameters are generated. From this distribution, we use Monte Carlo techniques to randomly sample array geometries for each simulated particle. Then we can calculate the deposition probability using analytical formulas. These formulas determine the effect of impaction, gravitational settling, and Brownian diffusion. The model calculates output data like total, regional, and generation number specific deposition fractions and deposition densities. Yes, now, as a short comment, I would like to say a few words about the different versions of the model that have been developed over the time. Initially, the model was implemented in Fortran, and it has undergone many improvements over the years. From a software engineering perspective, it became desirable to modernize the implementation. So we developed a newer version in Rust. So today we use two different implementations of stochastic LAN model, a more complex Fortran version and a newer, simpler Rust version. The Fortran-based model includes more physiological features. For example, it allows us to specify asynchronous breathing and diseases like asthma and COPD, and it can be specified for child or adult. The Fortran model is not user-friendly, so we developed the Rust version, which is more user-friendly, and it's available in OpenSLM website. Even though it's simpler, it still gives accurate deposition predictions, and its main advantage that it can be used by anyone through a web browser without the need of knowledge of software installation or programming. So in short, the Fortran version is more advanced, but it's harder to access, and the Rust version is more user-friendly and more accessible. And now I would like to introduce the web application we can access via this link.
Control.
Yeah. Czy masz kontrolę? So here we are at the homepage of the website, and the website is also available from mobile phone, but mobile modeling, I think it's not convenient, so I not recommend it. As you can see, there are several sub-pages, each with specific function or informational focus. The theoretical basis page is about the model's theoretical background and its development process over the year. The extensions of model and specific application section is dedicated to past application, showing the model has been used in various research contexts in the past. And we are very open and optimistic about new use cases, so we would be happy to write here future applications too. So if you use the model, please let us know, and we can post it here. About us and contact us pages are trivial, so let me see the random model section. First, we created a step-by-step tutorial to help new users use the OpenSLM interface. Then, description of the input parameter section. We think it's a very useful and helpful section, because we created here a description for every parameter that have to be defined by user, breathing parameters and particle parameters too. And here we give recommended value, reference value that can be used. We will talk about the model output a little bit later, but first let me make a run. The model will be accessible after a short registration. We ask users to enter basic information and their institute. It helps us to understand who is using the model and for what purpose. And I log in with a test user now. Yes, and after login, the random model page will be available. Here you can see the input, the interface where you can write the input parameters, and there are two more things to talk about it. Multiple run feature allows you to specify multiple values for a selected parameter. With this function, you don't have to do separate simulations manually. I know I choose particle diameter, but I could choose any other parameter. And here you can see I brought here 3 different values. Number of events is the number of simulated particle pathway. It is due to stochastic approach. The bigger number you use, the better result you would get. But due to our server capacity limitation, we limited number of events in 1 million particle paths. Other parameters are not limited, and I started the run. And now we have to wait for the running progress, but it will be short. Until that, we can talk about the description of the model output a bit later. I would like to say that the model output will be available in a downloadable zip file, as you can see here. And we created 2 simple diagrams to have imagined the results, it's the visualization section. We will talk about the results files. Here you can read the description about it in the description of model output section. There are 3 types of files are generated. Depo.dat is the most important file, the visualization based on this. This file provides a summary of deposition across the 3 main lung regions. Each row represents 2 different value of the parameters selected in multiple run. Geometry.dat file gives insights into the geometry of airways across lung generations. Each row in this file corresponds to a generation number, and due to stochastic approach, with the same input, different geometries are generated as separate runs. Output.dat file describes how particles deposit across different lung generation, and again each row corresponds to a generation number. Here you can see the description of the visualization. Yes, and this was the end of introduction the website. Finally, I would like to say that we are open any kind of feedback or collaboration about the website or the model itself. So feel free to contact us via contact us page or email. And if you will use OpenSLM for your work, we hope you will find it useful. Thank you for your attention.